Hi, everyone, and welcome to this session on shielded transactions. In this session, I'm going to be talking a little bit about when we talk about privacy, what is actually happening inside and how we can achieve it. We have been doing a lot of work at the forefront of privacy, especially in the Starknet ecosystem, because we feel like Starknet is a natural fit for privacy related applications and privacy related use cases. We have had a lot of interesting announcements that have happened in the last couple of months, and we will be having a bunch more in the upcoming months as well. So stay tuned for those. But for now, let's break down what are shielded transactions and how they offer privacy in the blockchain ecosystem. So the first thing is to understand what is the core problem, right? Now, everything on blockchains, especially public blockchains, is permanent and transparent to everyone. So every Bitcoin and Ethereum transaction, for example, is permanently public and searchable. You could search for anyone's ENS and figure out what they are doing. There is total wallet exposure in terms of how much balance you have, what you have been doing, what are your trading strategies, and every protocol that you have interacted with. This has real world consequences, right? Even though we do ask the question, is privacy important? Is it worth paying for? However, this exposure itself has consequences like exposed salaries. If you receive money in crypto, then everyone knows how much you make, right? Front running bots. Business intelligence leaks, especially for institutions that are looking to deploy capital. This is not so feasible for them to just, for everyone to know that, let's say they deployed $1 million and they can actually see that there's 5-10 million left in their wallet, right? And there's personal safety risks as well, especially with the growing tension across the world. It is privacy becomes more and more important from a transactional perspective, right? An example that I want to give is which is familiar, everyone must be familiar with etherscan, one of the popular explorers for ethereum. You could literally see everything here, right? Like, if I do want to know what vitalik has been doing, I can just say like vitalik.eth and figure out what he's doing, right? So um yeah, so you see, like, it's basically everything is exposed if you see what is happening, etc., right? I don't know if this actually Vitalik's wallet, but oh well, it is. So you can see all of the transactions, who he's transacting with, what is happening, or who he's receiving funds from, etc. This puts the person who is exposed at risk. And transparency, even though it has been one of the core selling points of blockchain, right? But for mainstream adoption, it's not just enough, right? So transparency is great, but what we want is proof that something happened, right? And that's what I'm going to be talking about as well. So the solution to this comes in the form of shielded transactions. Now, what does a shielded transaction do is, as the name suggests, it hides the sender identity, recipient identity, and the amount, right? And while it does that, it also uses cryptography at the underlying to prove that the transaction is valid. The sender has enough funds to send to the receiver, and there is no double spending that occurred, which was one of the core problems that kind of Bitcoin initially set out to solve, right? Which is avoiding double spending. So, what is the magic behind this shielded transactions and how it works, right? So, this is where the ZK proof comes into picture. You might also ask why privacy is becoming important now. What is the story behind it? One of the bigger reasons being that zero knowledge proofs have taken off in the last couple of years, and they have matured so much that now you can actually deploy them at scale. So, what does a ZK proof do, or a zero knowledge proof do? It lets one party, which is the prover, convince the verifier, which is the other party, that a particular statement is true without having to reveal information beyond the fact that it's true. So you can prove that you own a certain bank account without having to reveal how much money or how much balance you have in that, right? You can prove that you are the owner of a certain wallet, or you made a certain transaction through a particular wallet without having to showcase how much balance is there in that wallet. So the three properties that make this happen are completeness, which is the true statements should always convince the verifier. Soundness, that is, false statements can never fool the verifier. Both of these kind of sound like the same, but when it comes down to the mathematical algorithm, there is some work done that is to ensure that both of these would come true. And the last is zero knowledge, which is the verifier actually does not learn anything important except the fact that the statement is true. Now, there are two types of ZK proofs that you might have come across, and there are different blockchains that use different kind of proofs. But the two that are most popular, in fact, these are the only two ones that are are being done at scale. One is called Snarks and other is Starks. So at Starknet, we are the pioneers of ZK Starks. And you can see some of the differences here, that the proof size is relatively smaller in Snarks versus Starks, but Starks is now being used at scale as well. So the proof size is shrinking rapidly. There is no trusted setup required for Snarks, there is no trusted setup required for Starks, whereas it's required for Snarks. Starks are quantum resistant by default, and this gives them a huge edge because now that there are a lot of algorithms that are coming up, especially in quantum computing, that are able to break encryption, it is very, very important to understand what kind of technology that you're using. And of course, as I mentioned, Starknet are pioneers in the ZK Stark space. There are also other projects that are going on that you could look at. There's Monero, which provides privacy without ZK proofs. There is some mixing that happens, and it is private by default. Monero is a popular privacy project that you could check out. And there is Mimblewimble, which merges transactions together. There is some interesting stuff going on in the Bitcoin ecosystem as well, which is worth checking out. But these are the two popular underlying algorithms. And now let's explore what happens inside a shielded transactions, right? So what is actually shielding what is happening? So in a simple transaction, you move funds, let's say, from one wallet to another, right? So in this case, what happens is the funds, instead of moving directly to the wallet, first move to a shielded pool. And there is a cryptographic commitment that is created for it. The commitment is nothing but a fingerprint which proves that this transaction exists, right? So you say that, okay, something has happened, and you create a commitment for it. And then the second step is that the sender who's sending the transaction generates a ZK proof on their device. So again, in this case, you are using the concept of ZK proof, where you can hide certain information like sender, receiver, and amount, and just create a proof that this particular transaction is valid. That is, you're creating a proof that this person is the owner of these funds, and they are able to send transaction on this network from their wallet to another wallet. And no private data this way leaves the device, because you can also generate ZK proofs on your own device. A lot of scalability stuff have happened in this space, which I will probably make another video to explore. You can also generate client-side proofs. You can also generate proofs on mobile these days. So anyway, the next step is, once you prove that you own enough funds and you're able to send as a sender, then the network checks the proof, right? And it verifies that, yes, this proof is valid and the transaction is approved. And in the next step, there is a nullifier, which is published on chain, which marks spent funds as used. So nullifier is, again, an important concept over here, which we will break down in another video and go deeper into it. But basically, what a nullifier does is helps you prove that you have been able to spend certain funds, or it helps you to prove that you haven't spent those funds. So you submit a nullifier, or when a nullifier is published on chain, it says that certain funds from the sender have been spent, so they are not able to double spend, right? And in some other cases, the receiver also can use a nullifier to prove that they own the funds and things like that. So um, in this case, a simple thing is, you publish a nullifier on chain, which marks that the sender has spent the funds from their wallet. So if you want to see it visually, when you shield the transactions, instead of sending it directly to the wallet, it goes into a pool. You create a proof that you own these funds, right? And you're able to spend it. The network checks it, and the nullifier is published on chain. So what the public sees over here, that there is a deposit event that happened, right? They don't see who deposited, how much was deposited, and who's going to be receiving it. Nothing stays local, right? And then you just see that there is a valid invalid result of the verification, and you see a nullifier hash, which is just a hash, right? You can't decode anything out of that. So there is no amount, no sender, or no receiver that is ever published. The only on-chain data that you see is a deposit event and this nullifier hash, which is published, and both are unlinkable without something called as a viewing key. So now let's take a look at what this viewing key is. So, what is a viewing key and why is this important, right? So, we have been debating this whole privacy thing, especially with organizations like Tornado Cash coming up into picture. That is privacy actually related to accountability? Like, can you just do anything privately and get away with it? We think no, because privacy should be everyone's right, and but you should, at the same time, you should also feel safe in participating in privacy, because you feel that it will help you it will help you avoid leakage of data, rather than it will, it helps you do illegal things. So that is where accountability comes into picture, and that is where how we can have systems which are private but also regulated. So this is where a viewing key comes into picture. So a viewing key is a cryptographic key that lets an authorized party, which is like say an auditor or someone, read your transaction history without the ability to spend your funds. So if they want to verify that your source of funds, or they want to verify that you are a legit person and things like that, they can get access and they can look at that. However, they get only read only access, right? Which is what they need, and shared entirely on your terms. So this is for an individual, but from an infrastructure and ecosystem perspective, you can design mechanisms like how we've designed in Starknet to make sure that this entire privacy comes with compliance. So example could be, just if you, for tax purposes, if you want to show this, you can share it with your accountant, right? You can only allow your accountant to see this. They see the history, the public doesn't. So maybe you give them a viewing key, or you encrypt it together, or things like that, shared viewing key. If there are regulatory bodies, then for targeted legal disclosure. If you want to, if there are audits that need access to this information, then you can use the viewing key for the same. And if you want to prove something specific, right, without revealing anything else. So as the name suggests, it's literally used for, viewing, right? So privacy and compliance are not opposite two sides of a coin, right? They come hand in hand together. And now we have reached a point in Web3 where we can provide both of them together with the existing technologies. So these viewing keys are the one that give regulators what they need through legal process, while protecting everyone else's financial privacy. And this is very important, because here you see that not everyone gets exposed to all of this information, right? Only the person who has the viewing key has access to this information. So you can design systems in such a way that there is shared viewing keys and how they are encrypted and things like that, to ensure that only the information, read only access to the player or the person involved is revealed. Now let's look into who is building this today. I'll come from bottom up, right? There is, if you see shielded DeFi, a lot of different players are trying this out. Actually, let's start with the oldest one. Monero, released in 2014. I feel like Zcash was the first one, but for some reason, looks like Monero was ahead of the game, or at least maybe they launched their papers early on, made the announcement. So they provide privacy by default, and all transactions are private. They use ring signatures, stealth addresses, ring CT. There's more interest. I can expand on any of these later on. But there is no smart contract programmability. So you only can use Monero Cash and move it around privately. Now, the next and considered the biggest pioneer is Zcash, which launched in 2016. And they were the ones who released the first ZK-based shielded transactions at scale. popular even now. They provide transparent and shielded addresses. So it's proof tech, it works. However, it works a lot in silo and there is not much composability here. It's a standalone chain. There are other chains that are also trying to work on this, which is like Aztec, Railgun, Penumbra, and apart from Starknet itself, other ZK L2s are also trying to attempt this. However, Starknet is doing something interesting and new, right, in this era. That's because we are already built for our infrastructure, our foundational principles are already built for privacy. So we are going to be working with, protocol level shielded assets at scale. So it's going to be privacy at protocol level at scale. So you don't have to build separate privacy pools and things like that. It's all going to be at protocol level. You can get shielded DeFi with compliance. So you don't have to worry about, things like Tornado Cash. And we're going to achieve this through initiatives like through privacy primitives like Stark 20s and Stark BTC itself, a very, very innovative um, announcement that we made recently, where which is going to be bringing Bitcoin users privacy, right, through Stark BTC. More on these in the next coming videos as well. I'll break down what they do. Now let's talk about who needs this, right? This is the question, and what does it cost? So individuals having high net worth, who want financial surveillance protection and they want to avoid front running, right? So there is a cost associated with privacy. That is why we are looking at who needs this and who wants this. However, with the current tech and as the tech is scaling more and more, privacy is going to be extremely cheap. So anyone should be able to afford it at just down the line couple of months. Enterprises which are using payroll, so for private payroll, confidential payments, treasury management, you can definitely have privacy. Institutions, especially as more and more institutions are thinking about settling on chain for faster settlements, right? They would love to have confidential settlements. They would want to be auditable to regulators and invisible to competitors. And developers building privacy protocols, ZK identity, and MEV related work. Now let's look at some honest trade-offs, right? From a compute perspective, because you also have ZK proofs involved in them, it is heavier than transparent transactions. However, it is improving rapidly, as I already mentioned. From a UX standpoint, generating client-side proofs was a big blocker, but it is also being worked on a lot. As I mentioned, now you can actually generate client-side proofs on mobile, right? So you can have mobile applications that use this. However, it's still in early stages and improving as we go. The regulations around privacy is very uncertain, largely because the players in the past have not been very compliant. So it's going to take a little bit more time to understand, how the regulations would work in some jurisdictions. And if you use snarks, then you have a trusted setup risk, which is why you should use snarks. To conclude, I want to share that there are 6 things that you should remember. The core problem being transparency barrier, right? And this is where shielded transactions can hide sender, recipient, and amount while mathematically proving validity. The infrastructure or the technical competency that allows you to do this are ZK proofs. And as they are becoming more and more powerful, we should really explore how they can add value in the privacy ecosystem. Privacy and compliance go hand in hand. So, compliant privacy systems are the ones that you should be looking out for. There is a lot of rapid innovation happening in this space, especially in the Starknet ecosystem. So, check out all of our updates, information that is coming up. And for the future protocol phases, most of the protocols are looking at privacy as a default at the protocol level, right? Especially if you want to onboard institutions and strengthen your DeFi. So, shielded transactions overall give blockchain the one thing it was missing, which is the ability to prove a payment happened without telling the world who paid, who received it, or how much. Thank you, and I'll see you in the next session.